Okay, let's talk about the physics section of the exam, and that's the latest unit we've been doing, so it should be fairly fresh in your mind. One of the key concepts here is the distinction between scalar and vector quantities. Okay, scalar is amount, so in other words, how much of something you have. Could be a distance, for example, 10 kilometers. Can also be a speed, maybe 10 kilometers per hour, something like that. And vector is amount plus direction. Okay, so this might be displacement. So that's our change in position. Okay, so that would mean a change in position. Okay, so in order to establish a change in position, we always have to subtract two things. So maybe our second position minus our first position would equal our change in position. So this is often, delta D is often depicted as our change in position. Okay, so an example written out using the 10 again, this may be 10 kilometers, maybe north. So we put in square brackets and put north. So we have the amount of distance and we've got a direction. As a velocity, this might be 10 kilometers per hour north, something like that. Okay, so there's an amount and a direction. So these amounts, the amount is sometimes referred to as magnitudes. Same thing. Okay, just a fancier word. Okay, so with that we've got speed and we've got velocity, and so we end up looking at graphs. So we need to know a lot about graph interpretation and what they mean. So one of the first things to do with a graph is always look at, especially the y-axis. Usually the x-axis is going, in physics anyway, is going to be time, and be sure to check the units as well. So if it is indeed delta D, which is our change in position, and maybe that's in meters, then we need to know what the different graphs could look like. So maybe we had a graph that was like this. Okay, so that would be a positive slope. Okay, and then maybe one is a little bit steeper. Okay, maybe one that is starting at this position and not having any slope. Maybe even we're down here and we're down to a negative slope, or maybe could be starting up here and having a negative slope. Any of these would depict the velocity of the object. Okay, so the steeper the slope, equals faster. Okay, even if it's negative, so this would be a very steep slope just in the negative direction. So usually we'd have positive up here, and then to have the quadrant down below being negative, this would just be, maybe I should put that in the same color so you can see that it's the axis. So this is the quadrant below, and it would be negative. So this object here is moving very fast because it's very, very steep. The slope is very high, even though it's in a negative direction. Okay, this one right here, that has no slope. So the object is actually at rest. Okay, so this whole slope thing, this is something you'll come across in math class. Slope is equal to rise over run. Okay, now I won't give it to you this way, but this is the way you should be aware that it occurs in physics class. Slope is equal to velocity. Velocity is equal to the change in d, so this was your rise, all over your run, which is your time. Okay, and the units in this particular case will be meters over seconds, so meters per second. Okay, so you should know that the different graphs mean that. So now this kind of naturally brings us into the formula. So you're also responsible for being able to substitute in values. You're responsible for rearranging this formula as needed. For example, you might have in the question, you might have the velocity and the displacement, and you need to calculate time. If you need help with that, I've got a basic rearranging formulas video you can go see. Next, let's take a look at a velocity time graph. So we've got our time maybe in seconds still, and our velocity. So velocity would be in meters per second. Okay, so in just as in up above here, we ended up with a formula saying d over t. We're going to end up with v over t. So we end up with a change in velocity over time, and all that equals something called acceleration. Units wise, we end up with meters per second for the velocity divided by seconds. So this is meters per second, or meters per second squared. So whenever you see this squared up in the exponent of the denominator, you know you've got an acceleration. Okay, so an acceleration here would look like some slope on a VT graph. So A, for example, would have a greater acceleration than B in this example. Okay, so how does an acceleration look like on a DT graph? So if we're sitting here with displacement and time, we are looking for an area that has a curve. So if there's a curved area and then maybe more straight, so from here to almost the beginning here, this curve is an acceleration, or non-uniform motion. Okay, so that's an acceleration. And I tried to draw this one a little bit more linear, let's say constant velocity, just as an example. Okay. All right. What else have we got? Here are the formulas that you'll be given. The average velocity is equal to total distance over total time. Another way is average velocity is like two numbers. If you had v1 plus v2 divided by 2. Just in general, velocity equals delta d over t. You would have acceleration is equal to delta v over t, which is equal to vf, which is final velocity, minus initial velocity all over time. You'll have this other formula here, is a very useful one. Delta d, so a change in position, is equal to vit plus 1/2 at squared. So when you have all the variables except for one, then you can solve for the one that you don't have. Let's see now. We have another one that we haven't used too much, but it's just as useful. If we have delta d is equal to vft minus 1/2 at squared. So you can see this one here, if we don't have vi and we do have vf, we can use that formula. Here's another really good one and useful when you don't have time. So this is vf squared is equal to vi squared plus 2ad. Okay, so you're responsible for knowing how to rearrange these, but I will give you these formulas to begin with. Okay, and another constant that you should have or will be available to you is the acceleration due to gravity, and that is equal to a negative 9.8 meters per second squared. Okay. That's about all for now. There will be some multiple choice. There will be a few problems to work out as far as calculating and then there'll be graph interpretation and graph plotting. Okay, that's about it. Good luck.